Okay, in this video we're gonna look at some IGCSE past papers and just see if we can figure out how to do the indices part. So in this one we have 216 y to the power of 216 and it's all to the power of 2 over 3. So when I see something like this 3 would usually give me away, it kind of gives it away that this something multiplied 3 times is going to give me 216. So again, there's two ways of doing this. The first one, let's just do this way over here. So what I would do is I'd take the cube root of this number, 216 y to the power of 216, and all of this would be raised to the power of 2. So there's 3 obviously for the cubed, and the numerator for the square at the end. And now I can take my calculator and I can probably guess. I know 5 times 5 times 5 is 125, so 6 times 6 times 6 would probably be 216. So this is actually the cube root of 216 is 6. And when I have like the powers or these indices under a square root, what I have to do is I have to take this number and divide it by that number. So this is a big number, so let's just take a silly example. Let's say I had the square root of, let's say, x to the power of 4. So what this would mean is, what do I have to multiply with itself twice? X to the power of something times x to the, okay, maybe I should just make a little block there. X to the power of something times x to the power of something should give me something like x to the power of 4. So I know with this, the rule is I have to add the numbers. So this would be 2 and 2, which would add 4. So in this case, the 4 divided by that 2 would actually give me the answer. Let's look at another example. I know we're busy with this one, but let's just do something else. Let's say it was the cube root of x to the power of 9. So my question is, x to the power of what times x, x to the power of what times x to the power of what times x to the power of what would give me x to the power of 9. So basically I just take 9, there's 3 of these, 9 divided by 3, so it would be 3. So whenever I have a variable, and an indice, well, in this case, the index of 9, then I would just take 9 divided by 3, which would give me 3. So in this case, I just have to say 216 divided by 3, and I think that's 72. So y to the power of 72, all squared. So 6 squared is going to be 36, and y 72 times 2 is going to be 71, 144, if I'm not mistaken. Okay, so I think this was a very tricky one. It's probably the most tricky one I've seen, just because the two numbers are very big. But let's take a look at some others. So that one's done. Let's take a look at our next one. Okay, so find the value of 64. I'm going to put that there. 64 to the power of 2 over 3. Now, I love seeing the number 64. Again, I can go, I forgot, I didn't do the other way with the previous example. Let's quickly do that. Sorry about that. Let's just bring that one back and just write it down, so I can do it both ways. Ooh, that wasn't very good. Anyway. Okay, so what I can do here, if I didn't want to do the cube root, no pun intended, is I could change this to 6 to the power of 3 and y to the power of 216 all to the power of 2/3, and then I would just multiply this with both numbers. So in this case, 3 over 1 times 2 over 3, those would cancel out, so I would have 6 squared. And in this case, I'd have 216 over 1 times 2/3, 2 over 3. 3 would go in itself once, and it would go in there 72 times. 72 times 2 would be 144. and then I can just write 36, 144. So both ways would work. Okay, let's try not to forget to do both ways with this example. Okay, let's make arrows so that I won't forget. So the first way, this is my favorite when I see 64, is just changing it 4 to the power of 3, very simple, and then 2 to the power of 3. And now I know this 3 and that 3 will cancel out. I'll just write it for you to prove it. 3 over 1 times 2 over 3. 3's would cancel out, and I'm left with 2 over 1. So basically this is just 4 to the power of 2, which is 16. If I wanted to do the other way, I could have taken the cube root of 64 and just squared it. So remember the 3 is the cube, and that 2 tells me a square. Cube root of 64 would be 4, and then that squared would just be 16. You can use either way. I like this way. Doesn't really matter which one you use, both will work. Okay, that one's done. Where's the next one? Here's another one. So x to the power of 8 and y to the power of 7 divided by x to the power of negative 1, y to the power of 3. So in this case, I think they put those brackets there just to confuse you, because they're not really needed. So I'm going to rewrite without the brackets. We don't need the brackets. Oh well. X to the power of negative 1, y to the power of 3. And now we know if we divide the indices, we just subtract them. So in this case I have x to the power of 8 minus, but that's a minus 1, minus 1. And in this case I have, oh sorry, not equal sign, y to the power of 7 minus 3. So 8 minus minus 1 is going to be 8 plus 1, which would be 9. And y 7 minus 3 is 4. Cool. That was a quick one. It looks very weird, but yeah, pretty simple. Let's go take a look at what do we have next. This is nice. Simplify n to the power of 5 times n. That would just be n to the power of 6. Very straightforward. So that was A. For B, I have 8x to the power of 6 divided by 2x to the power of 2, all squared. Okay, so the numbers first. 8 divided by 2 would be 4. And when I divide the indices, I just minus. So it's 6 minus 2 is 4. Okay, easy 2 marks. Well, 3 marks if you think about that. Yeah, let's take a look at the next one we have. Okay, this one is, I chose it because it has the negative y indice, but it is in an equation. So if you haven't really done equations yet and you haven't watched the series on equations, this might not make sense to you right now, and that's fine. So you first have to, this is like two things combined. Knowing how to manipulate an equation or a formula, and also working with indices. So don't stress if you don't know everything about this, but I'm going to do it anyway. I'm just going to rewrite. So we have the 3 and we have a 2 to the power of negative y. Remember, I can't multiply these two things because this is raised to a power. I can't say now 3 times 2 and then that raised to the power, because then suddenly the 3 gets raised to the same power. So if you had any thoughts of doing that, don't do that. Okay. Now the magic thing when we have an equation is, and we have fractions, we can make fractions disappear. I love letting them disappear. Fractions are a little bit difficult, and like if I was writing on lined paper, I'd always try and get the fractions gone first. So first I have to check how many terms there are. So this is one term, that's another term, that's another term. So I want this fraction gone. I'm going to multiply each term with 16. So multiplied by 16, multiplied by 16, multiplied by 16. So if I multiply here by 16, they would cancel out, and I'm left with 3, and this 2 to the negative y. This minus 1 times 16 is going to give me negative 16, and a half times 16 is 8. Okay, so now I have this. Next, just taking that over, or adding 16 on both sides. So 3, 2 to the power of negative y. So 16 here, adding 16 here would cancel it out. Adding 16 there would give me a 24. Very nice, I can divide both sides by 3. So the 3's would cancel out, and I'm left with 2. Oh, that's not a 2. 2 to the power of negative y. And here I would have 8. So if you get here, that's pretty cool. You might think you're stuck, but 8 is such a nice number because it's a cube number, and we can, this is again for me a giveaway. So I should rewrite this number as with a 2 as a base, so in index form. So 2 to the power of negative y is going to be 2 to the power of 3, because 8 is the same as 2 times 2 times 2. So now I know the base numbers are the same, so obviously this has to be equal to that. So I can write negative y is equal to 3, but I don't want negative y, I want y. So I divide by negative 1 on both sides, and I would have y is equal to negative 3. Kind of a long one there for only 2 marks, but yeah, interesting. I really like that one. Okay, next up, another old paper. I see same one's been asked, so I'm not going to do those two, but there's a new one. 2, 4, 3 y to the power of 20 2 over 5. Okay, so the 5 there is kind of giving it away for me. So I'm assuming this number, if I multiply it 5 times or something 5 times, I'm going to get to that number. This numerator, the denominator kind of gives it away for me. So again, we'll do both methods. Your choice, which one you want to do. Okay, so let's do the 5th root. I think it's called 2, 4, 3 and y 20, and that's all going to be squared. So remember that 5 is that 5 and that 2 is that 2. So now I have to ask myself, what will I multiply 5 times? Where is my calculator? Here, calculator. Okay, so let's try 4, maybe will not be enough, 5 won't be enough. I wonder, let's try 4 times 4 times 4 times 4 times 4. No, too much. Let's try 3 times 3 times 3 times 3 times 3. That works. So 3, so this is just going to be 3. And now I have to remember this is 20 divided by 5. So 20 divided by 5, which would be 4. So I have y to the power of 4. And this is all squared. So here I have 3 times 3, which is 9. And I have y to the power of 8. Let's just do the other method to see if we get to the same answer. Hopefully I didn't make a mistake. In this case, let's just rewrite 243 as 3 to the power of 5, and the y to the power of 20 just stays that way, all to 2 to the power of 5. So I just multiply this in, so 2 over 5 times, that's a 5 over 1, that would cancel out, so this is 2, so we just have 3, multiply that with each other, to the power of 2. And this one would be 20 over 1 times 2 over 5. 5 would go in itself once, and into 20 it would go 4 times. 4 times 2 is 8. So I'm left with a y to the power of 8, and then I can just do 9 to the power of 8. Okay, so both methods got to the same answer. I just had to kind of try a couple of stuff with my calculator. Like I said, I usually see more of the 125s, 64, 27, and 8. So yeah, I haven't seen 243 being used too much. Well, at least not last year. Anyway, I think I have some more. Let's go do some more. Some more indices. Okay, 2 more on this paper. 3 to the power of 3p times 3 to the power of 2p is 729. Now 729 looks like a number. I've seen that number before, but let's just take a look what we have to do. So I have two base numbers. So when I multiply these base numbers, I can add the exponents or the indices. In this case, they can be added. So this will be 3 to the power of 5p is 729. Now, usually when you get to this stage, you might be like, oh, I don't know what to do. But again, this base number is a giveaway. So I assume that I should be able to write 729 as something to the power, so as 3 to the power of something. So I should be able to do this. I just don't know what this is. So I'm going to try my calculator and do 3 times 3 times 3 times 3 times 3 times 3. How many times did I put? 1, 2, 3, 4, 5, 6. 729. Ooh, I wonder how I knew that. Anyway, you can just play around, but 3 to the power of 6. So now the base numbers are the same, so I would know this should be equal to this. So 5p is equal to 6, but I don't know what 5 times p is, so I'm going to divide by 5 on both sides. So p would be 6 over 5. I would probably write this as a mixed number or maybe as a decimal, but rather this than just keeping it that. But this should be fine. Nice. Okay, we have another one here, 32. So 32x to the power of 10 to the power of a fifth. Again, there would be two ways of doing this. Guess which way I like more. I'm going to go with my favorite way first. 32 I know is it's 2 to the power of 5. Again, that 5 would kind of give it away. I'm not saying you should assume that, test with your calculator, but I'm fairly sure 2 times 2 times 2 times 2 times 2 is 5. And this x to the power of 10 I'll just leave like this, and then that would be a fifth. If I multiplied a fifth times 5, that would just be 2. And in this case, it would be 10 over 1 times 1 over 5. The 5 would go in itself once and into the 10 twice, so I would be left with x squared. Okay, other method is taking the root method. So we have 32x to the power of 10, and this all will be power to the power of 1. Could have left the brackets out in the power of 1 because it's not really making a difference. So this would be 2, and 10 divided by 5, that would be 2. Same method. Well, not same method, but same answer. Okay. Hope you're enjoying this video. I'm definitely enjoying this. I love these questions. There's about, if you're wondering how far we're going to go, there's 2, 1 here, and 3 there. So almost done. We're going to do 4 more, and then we're going to wrap it up. So 64 to the power of y to the power of 27, 2 over 3. Again, when I see 64, I just know it's going to be 4 to the power of 3. Just rewrite that. It's kind of usually a giveaway. And then that to the power of 27, all to the power of 3. By this time, you would know that 4 to the power of 3 to the power of 2/3 is going to be 4 squared, because those cancel out. And then in this case, it's going to be 27 over 1 times 2 over 3. 3 would go in itself once, and into 27, 9. Oh, sorry, that's not a 9. 9 times, and 2 times 9 would be 18. Okay. Okay, let's just do it in number form. So that would be 16y to the power of 18. Do the other root method. I'm just going to take this calculation away. So it would be the cube root of 64 y to the 27 all squared. Again, that 2 is that 2, and this 3 is this 3. Okay, cube root 64 is just going to be 4. 27 divided by 3 would be 9, all squared. 4 times 4 is 16. 9 times 2 is 18. Cool. That was pretty cool. Next one. Yeah, it's probably like the longest video ever. Okay, this one, 5 to the power of n is 1 over 125. I like this one because this is like those recurring numbers that you see a lot. So 5 to the power of n, I know this is going to be 1, let's just say 1, and then that 5 is probably going to be 5 to the power of 3. Okay, 5 times 5 is 25, times 5 is 125. So I just changed that up, but I still have this kind of issue what's going on here. So 5 to the power of n, I can move this up, just get the inverse, or it'll change into a negative index, and now I know n is negative 3. Okay, I don't know if there's a different way of doing that. I think that's pretty much straightforward. If you know of a different method, please write in the comments. Maybe you know of something that I'm missing. Always enjoy learning more stuff as well. I don't know everything. Okay, next one. Again, I like the 64, so I'm gonna go and change that 64 into a 4 to the power of 3, and this m to the power of 3 I'm gonna keep, and then a negative 1 over 3. So in this case, 3 times a third is gonna be 1, but it's gonna be negative 1 because that's a plus times a minus is a minus. 3/3 is 1, and in this case we have m, again 3/3 is 1, so we have m to the negative 1. So both negative indices, so I can actually just switch them around. This is the same as m over 4. Okay, different ways of writing this. M over 4 can work, or a quarter of m can work, that's the same, or even 0.25 m. All of these would be the same. But yeah, I think in the memo all of these would be fine. Okay, last one. We made it to the end of the video. Can you believe it? Haven't we done this one before? I've seen 64 so many times. I mean, this is all a lot of last year's papers, and you can see that like this number gets used a lot. So again, two ways of doing this. You can do the cube root way, saying the cube root of 64 and get that squared. So that is going to be 4 squared, which is 16, or you could have changed this to 4 to the power of 3, just changing that number, and then that would be 4 squared, which would still be 16. Okay, well, that's all last year's indices that I could find in past papers. If you have any others that you want me to look at, please write in the comments or something. But yeah, thanks for watching.